Alright, so if you haven't watched the first video already, have a go at that. But this video is really kind of diving a bit more deeply into moles. We're going to go through some of the more technical aspect of moles. We're going to go through some of the stuff that I brushed over last time. They're going to be more in depth. This is if you're interested in moles and just really want to do well in the HSC. But it will be more complicated. So last time we kind of brushed over the AMU. So the AMU is actually a little bit more in depth. First of all, it's sometimes called the atomic mass unit. Other times it's also just called the U for unified atomic mass unit. But in either case, what we actually did, no one actually sat there and counted all of the atoms. What we actually did is we actually just determined the mass of one AMU in kilograms directly. And the answer was 1.660540 times 10 to the power of negative 27 kilograms. So one AMU is equal to this tiny amount of mass there. And so if you wanted to derive the mole, right? so if you wanted to get one mole, that would simply be 1 over 1 gram divided by 1.660540 times 10 to the power of negative 27, but multiplied by 10 to the power of 3 to convert it into grams, to convert the kilograms into grams. So if you do that right now, then you will get 6.022 times 10 to the power of 23 atoms. So you can see that this is actually how we derived the mole. No one actually sat there and counted it all. So that is how we got the mole. Now, to go into a little bit more depth with how the mole was originally defined. So you'll notice that hydrogen, if you look on your data sheet, is actually 1.008, and there's a few reasons for why it is so. And if you have a look at, like, let's say helium, and this it's weird because hydrogen only has 1 proton, so you would expect it to be 1. Helium is 4.0026 and has 2 protons plus 2 neutrons. There's 2 reasons for this. We'll go through the first reason. Is carbon-12 is standard. So for some reason, I don't know why, they could have let, say, hydrogen be 1. They could have let hydrogen equal to 1, but they didn't. I don't know why. They decided to say carbon-12 is equal to 12 AMU. Probably because carbon-12 is more readily accessed. Who knows? So the other part of the old definition kind of relates to this, and this was that 1 mole is equal to the number of atoms, number of carbon-12 atoms in 12 grams of carbon-12. That was the old definition. The new definition just defines it directly, right? The new definition just defines it directly. So, so we'll actually come back to why carbon-12 being the standard results in things not being exactly 1. We'll also have a look at the second. We'll have a look at the second reason first, which is the fact that isotopes. So you'll notice that even carbon is 12.01 AMU. And you're like, what? How? It was defined as 12, right? And the problem is that there are also carbon-13 and carbon-14 isotopes. So the way that they actually determine this number is that it is the weighted average. So the atomic mass is equal to the weighted average. It's the weighted average of naturally occurring isotopes. So you know, basically what scientists do is that they look around in the atmosphere. They're like, okay, you know, maybe 99% is carbon-12, 0.7% is carbon-13. I'm not sure about the exact numbers. 0.3% is carbon-14. And then what they do is they do the weighted average. So they'll do 0.99 times 12, carbon-12, plus 0.007 times 13 plus 0.003 times 14 might give you 12.01. So that's the second reason. The other, so back to the first reason, because carbon-12 is the standard, and carbon-12 is 12 AMU, the reason why I wanted to go through this a bit secondly is because it gets more kind of involved. Because of E is equal to mc squared, inside the nucleus, right? Inside the nucleus, when you have all of these, so the thing is, because you have all of these protons and neutrons all huddled together there, because you have all these protons and neutrons huddled together, the issue is because they are so, because they're kind of pushed together, they actually have a lower energy state because of the strong nuclear force. The energy state of the protons and neutrons in carbon-12. This means that it's going to be very low energy, and you can see in E is equal to mc squared. If E is low, mass is low. So therefore, that explains why hydrogen, because it's naked by itself, it doesn't have the strong nuclear force to reduce the energy state. So E goes up, M goes up. That's why it weighs a bit more. But don't worry about that. That's something that you'll explore more in physics in year 12. But yeah, okay. So let's go through some questions. I want you to have a go at these ones. Let's have a go at these 3 questions. You'll need your periodic table. Okay, let's have a go. Alright, cool. So let's have a go at these questions. So 53 grams of zinc. So 53 grams of zinc. Okay, well, first of all, I want to figure out the molar mass of zinc. The molar mass of zinc from the periodic table is 65.38. So therefore, the moles of zinc is equal to the mass by molar mass. The mass here is 53, divided by the mole mass of 65.38, which gives me 0.811 moles. So part B, 700 million atoms of uranium. So remember, N is equal to N by Na. 700 million, 6.02 times 10 to the power of 23. Oh, that's not a lot of moles. 1.16 times 10 to the negative 15 moles. Even 700 million, which is a lot of things, is just a tiny amount of moles. Finally, 19 kilograms of uranium. So the molar mass of uranium is 238. So each mole of uranium will have 238.03 grams. So this would be 79.8 moles of uranium. Okay, cool. one last thing that I want to go through before we end this relatively more advanced part of it, is the molar mass of compounds. So the molar mass of compounds, so for example you have something like SO4, right? How do you figure out the molar mass of this compound? Well, it's simply just, so the molar mass of this guy is just the molar mass of sulfur plus the molar mass of oxygen 4 times. Because it's 4 oxygens. Or in other words, it's the molar mass of sulfur plus 4 times the molar mass of oxygen, which gives me 32.06 plus 4 times 16, which is going to give me 96.06 AMU. Let's have a go at this. So what is the mass of can't type. Please have a go at this question. Please have a go. Alright, tell us, Jimmy, you've had a go. So first we have to find the molar mass of CO3, which is actually going to equal to 12.01 plus 16 times 3 is equal to 60.01. Do not round it to 12, you're going to get the wrong answer. So moles is equal to this. Okay, so that's the number of moles that you have, right? So that's the number of moles of CO3 molecules. So that's the number of moles of CO3 molecules. And therefore, we're going to say that moles is equal to mass by molar mass, right? So therefore, mass is equal to molar mass times the number of moles you have, which is equal to 60.01 times the moles, which is 6.6 times 10 to the negative 12. Which is equal to 60.01 is equal to 3.99 times 10 to the negative 10 grams. Cool. Hope you enjoyed, and if you want some more, check out our website. Other than that, I hope you enjoyed, and I'll see you guys next time. Bye bye.